Okay, well, thank you. And I guess I have the honor of being the last presenter for the afternoon in 3 days of what's been, as much as I could catch given my day job, a really amazing array of science that's going on in the parks. I've been really impressed with it. So what I'm going to do today is talk to you about archaeological investigations at Fort Clatsop, particularly the ground penetrating radar investigations that I've been leading out there, and a few other elements of that. There's a lot to talk about in just 10 minutes, so I'm going to give you the extremely brief version here. Okay, next slide, please. Right, so there's two renditions of Fort Clatsop. One is, of course, a sketch drawing there in the lower part of the slide, and then the actual replica put together at the Lewis and Clark National Historical Park, out just south of Astoria at the mouth of the Columbia. So Fort Clatsop is, of course, the westernmost base camp of the Corps of Discovery. Lewis and Clark and their entourage ended up at the mouth of the Columbia late in 1805, stayed there for just a few months, and skedaddled back upriver and back east in the early months of 1806, March and through April. And this is the site at which the fort was built by them for protection for the overwintering. It may not be the exact location. It's as best as can be gleaned from the diaries and the records and a general assessment of the landform, and lots of Lewis and Clark experts who, you know, I'm not one of. I'm just the archaeology guy. So no physical remains of the fort have actually been found in terms of the structural remains. So there's been this longstanding search for Fort Clatsop. Next slide, please. There has been a lot of archaeological searching for Fort Clatsop. This is a rendition of the archaeology around that replica you saw in the last slide. The fort is the rectangle or square in the middle, and then all those red lines you see are trenches that were dug, and there's a picture of the trenches down in the lower portion of the slide, done by an archaeologist, Schumacher, who went and used mechanized equipment to dig long extended trenches around the replica to try and find the actual physical remains of the fort itself. So yeah, there's been archaeologists out there looking for it since the 1950s. The replica was built in 55, and this archaeological work happened shortly thereafter. There's also some blue, more block excavation areas identified there by Kaywood, who also dug at Fort Vancouver in the 50s and 60s. So yeah, a lot of searching for physical remains of the fort. And next slide. There's also been geophysical investigations, looking at the subsurface without having to disturb that subsurface, using things like ground penetrating radar and magnetometry and electrical resistivity and soil chemistry profiling and things like that. So a lot of effort to find some physical remains of the fort, but nothing's really been found, no smoking gun. And you can see there's quite an array of different pursuits all around that replica. So next slide. So just in the last couple of years, there's Glen Kirkpatrick, one of the co-authors of this paper and a member of the Lewis and Clark Trail Heritage Foundation, explaining to me, he called me up and he explained in a presentation out at Fort Clatsop that maybe the actual maybe the actual fort was somewhere to the north and east. He had re-examined some of the journal entries and had done some measurements and calculations based on historic settler observations that maybe the fort was actually to the northeast of where the replica sits now. So he asked me if I could come out and do some geophysical investigations. And like I said, ground penetrating radar is mostly what I do. That's what I utilize as an archaeologist to look for indigenous plank house villages and settlements under the surface. So I said, sure, and assembled a team to take that on. So next slide. Our study area was, as I mentioned, to the north and east of the reconstruction, and Glenn had communicated to me that the fort might be there, and also had come up with another additional interesting detail that there may have been a palisade on the front of the fort. There were some references to a palisade that had a dug trench and pickets in it, and this would be interesting because it would create a subsurface trench that would be dug and the pickets stood up in it. So it would actually create some kind of subsurface impact where the rest of the fort was likely just built up of logs on level ground. And so it would be relatively invisible to things like ground penetrating radar and even wouldn't leave much of an archaeological trace at all. But this palisade might have been something that GPR could pick up on. And this palisade would have been at the edge of the ridge, likely overlooking down to the river that was a couple hundred meters down. That canoe in and out travel would have been most likely done on that river. So he had this new idea about where this fort would be and can GPR find it. So yeah, that was really our task. And so next slide. Interesting challenge. There's lots of challenges to trying to find this kind of structure with ground penetrating radar. I mean, it really was a short-term use structure, 3 or 4 months. So it wasn't built to last. So it wasn't built to have a large subsurface footprint. So very limited in its expression in the subsurface. And really just the palisade would be the only thing we would have a hope of seeing likely through ground penetrating radar or even traditional archaeological investigations. And you know, really, the ground surface has been substantially disturbed by archaeologists since the 50s. So that is actually obscuring our ability to see the fort itself. And I'll get to that in a minute. It's interesting how well we can see the past archaeology with these ground penetrating radar methodologies. There's a lot of past research, obviously, to draw on that we could utilize to guide our studies, but a lot of those were done with pretty antiquated equipment, and they weren't really reported in a consistent spatial way. So it was difficult to really put that all together, although that's a job we're definitely taking on, is to try and also compile a lot of the past research into a consistent geospatial or GIS framework to put all this research together and see what we can take forward from that. So a lot of challenges in this. Next slide, please. Just a shout out to the team. I directed the operations. I'm at Washington State University, Vancouver, as I mentioned. I have my Northwest Coast Archaeology Lab, which I'm sitting in now. So I got my graduate students, Tyler Baley and Kate Chantry and Cameron Blumhart, to come out with me. Also joined by Marcia Small, who's a doctoral student at Montana State University, a member of the Cheyenne Nation. And I often work with Marcia in the context of using ground penetrating radar to find missing children and unmarked graves around Indian boarding schools and residential schools, which is another hat I wear in a different world. Funding came from the Lewis and Clark Trail Heritage Foundation, obviously WSU as well, in that they fund my work, and my National Science Foundation grant, which is really to do this kind of ground penetrating radar work in a variety of different contexts. And of course, shout out to the National Park Service, and Rachel Stokeld out there was really instrumental in helping get all this off the ground. So just a shout out to them. Next slide. 2 rounds of field work. We drove out there from Portland and did a round of field work in April of 2022 and September of 2022. And a couple reasons for that. Thanks. Sample size of 1 is always the worst on which to generalize. So we did it twice. One is in a really moisture saturated conditions and one in really dry conditions, and they can respond differently to GPR. So a couple rounds of field work just to make sure we got some solid data. Okay, next slide. Ground penetrating radar, I don't really have time to explain it in any technical detail, but yeah, there's a machine that sends a radar wave down into the ground and it bounces off things that are different down there, be they stone foundations or different soil conditions. So, you know, just sending a beam down and having it reflect back, recording that signal, and it creates a transect or a line of data. You can see what's called a radargram up there. That's one kind of data we collect, just a long line of pulses into the ground and compile that into a long line of data. Next slide, please. We can compile those lines into an arrangement called a grid, and then we can slice it horizontally so we get essentially a bird's eye view where the reflective hotspots show up really well with a lot of processing and fancy computer work that I won't get into here. But we have 2 views from the side and kind of a bird's eye view at any depth down to the extent that the radar penetrates, which is usually about 15 feet or 5 meters. Next slide, please. So yeah, fieldwork, a lot of it. We also did total station mapping where we were doing all our GPR survey. We used GPS data collectors to place all our data collection grids into their proper location on the landscape. So that's another whole component to it, is running the transects with the GPR machine, but also spatial control over where the data is coming from, so we can put it back onto the land surface in, say, Google Maps, and also, as importantly, down on the ground when we get out there. So next slide, please. It wasn't all hard work. We had some fun and did some demos out there for the Lewis and Clark Heritage Trail Foundation folks who came out there, and general passersby and the Park Service folks. So a lot of fun just to demo the gear. And next slide, please. We could process the data in the field, take it off the machine. I had a laptop computer there, and we could get the results almost instantaneously with a bit of computer work. It was nice. You get this feedback. You can do a bit of work, see what's down there, expand your survey area, that kind of thing. Okay, next slide, please. So some of the results, yeah, interesting. I'll go through these quickly. I won't get down in the weeds on this. We surveyed an area to the north and east of the replica. You can see these are different depths at which we can resolve what's underneath the surface, 0.5 meter down to 2 meters, and whatever interval we want. The red blotches are the hot spots, the highly reflective areas. And if you go to the next slide, I've chosen one depth at 1.5 meters down. What we really picked up was a lot of these trenches from the 50s, other archaeologists' work. You can see all the red hotspots really align with the maps of previous trenches that were excavated. So GPR is finding those old trenches, and it should, because those are soil disturbances that should reflect in the GPR system. Unfortunately, what that does for us is it kind of makes seeing Fort Clatsop trying to hear someone whisper in a noisy room, right? There's all this other disturbance, and it really seemed to swamp a lot of everything else. So next slide, please. Same thing in this other grid, this area, a larger square area we did in the middle of that study area, and you can jump to the next slide. We could see the trees at the top. We could also see what we thought was K-Wood's excavation down there. So we're also good at finding these big block excavations. And unfortunately, we didn't see a lot else. So I don't think we really were able to pick up any subsurface impacts of the fort itself. So next slide. Yeah, next slide. This might be a little bit of delay there, but to wrap it up, I mean, we took a good college try there and looked for what we thought would be a high probability feature, the Palisade. We didn't really find anything, but we certainly know where our previous archaeologists have looked. That helps us in that we can put it together in terms of our big geospatial database, maybe make a plan for doing a variety of different geophysical methods and approaches. So the search continues is really all I can really say about the results here. And that's kind of archaeology in a nutshell. Sometimes you just don't know what you're going to get. You give it the good old college try, learn from that, reframe your questions, take a different look, and see what we can come up with. Maybe there's a whole nother round of GPR in the future. We'll see. What we're going to probably turn to is a lot of more GIS potential model for where this fort could be based on landscape characteristics and other kind of dimensions like that. So next slide, and that'll probably be the end of it. Oh yeah, I already covered this. So jump to the next slide, and that's just a shot of all the people that were out there having fun over those couple of days. And yeah, I'll open it up to questions. Thank you.
All right, thank you so much. See a little red dot from the chat already. Carla says the search continues.
It does.
This is such an interesting project because, like, on one, like as you said, on one hand, it's kind of like womp womp, like, didn't find it, but on the other hand, there is a lot of interesting stuff that's come out of this. Like you said, finding the archaeological trenches. Let's see. Carla also has a question. What is the maximum depth GPR can penetrate to?
It depends on the frequency of the antenna you use, but we use a 350 megahertz antenna, which is pretty good down to about 15 feet, so about 5 meters. You can get GPR units that penetrate much deeper, but actually the resolution of objects is much coarser. So there's this inherent trade-off in GPR. If you want a real fine-grained view of the subsurface, you don't get very deep. And if you want a real deep look, you don't get very fine-grained. So we use that 350 megahertz antenna in archaeology because, not much deeper than 5 meters is of interest to archaeologists, except in exceptional circumstances. So that's about the extent to which we can see. And that should cover off anything Fort Clatsop because, there hasn't been a lot of deposition up on that ridge. And, if anything, there's probably been soil loss there. So that should cover off most of what we need.
I was also wondering if you could, as we wait for any other questions, tell us some more about there was a public demonstration of the GPR system. Is that this group here?
Yeah, this was the first round of fieldwork in April, and that was when Glen Kirkpatrick of the Lewis and Clark Trail Heritage Foundation gave his kind of pitch for why we should look at somewhere else and that kind of thing. And that was part of a meeting of that foundation. So a lot of those members came out, and then a few people from WSU came out. So this is just who was there on that day when we gave a demo. The second round of fieldwork was just a smaller, more in and out kind of day. We didn't really have a big public engagement event that day. So this is all the people from the Heritage Trail Foundation, or the Lewis and Clark Trail Heritage Foundation, and a few other folks that were around that day. You know, when you're pushing a GPR machine around in a public park, people kind of come up and sort of, you gather a group like a Pied Piper pretty quickly.
Good to be proactive about telling people what you're doing. Fred has a question. He says, any other structures like toilets or flagpole poles that might be visible?
Yeah, that's a good question. You know, if we get away from just the structural remains, what else might have been built by Lewis and Clark and their entourage over that time that GPR would potentially pick up, or even traditional archaeology excavation would? And yeah, you'd think they're pits, you know, toilet pits for sure. Privies are something that, you know, are dug and used, and those create different soil compositions that GPR theoretically should pick up. You know, post holes, like say you mentioned a flagpole, something like that might be interesting if it was particularly a pole that was, let's say the base, a bunch of rocks were added to stabilize that pole, and those rocks are still there because the pole decomposed in place or something like that. You know, that cluster of rocks would be something that GPR would really, really pick up on. So we kind of have to think our way through all of these different kind of things that would have been part of the regular cycle of life activity and how those might have some GPR expression. But we didn't find anything. Again, the landscape is surprisingly complex there in terms of human land use since the fort was there. It was cleared and tilled and farmed and all that kind of stuff, and stumps burned. And so there's been a lot that can just scramble that signal. Like I said, a person whispering at a noisy party or something is really kind of a good metaphor for what we're trying to hear.
And then we've got, a comment from Bob. I think the next attempt should concentrate on the areas where the 19th century Shane and Smith houses were located, as there's decent survey data on where they were and can be used as a model on structural remains on that plateau. So there were those two houses that were in your project area. Those were from the 1850s? Was that what it said? Yeah.
Yeah, right. Those pioneer or settler houses, and a lot of their observations on where the fort was, because it was in ruins, I guess, when they settled the area there, and said, oh yeah, the fort's 80 feet from our front step or something like that. So yeah, I think Bob's right. If we can look at those, and I think Glen Kirkpatrick has done a bunch of triangulation of measurements to try and pinpoint that area where he thought the fort was and where we looked. But maybe, yeah, that's a really interesting suggestion. If we run GPR over the Shane and Smith houses, kind of get a sense for how a century-and-a-half old structure looks in terms of GPR. I mean, maybe there's good historical documentation of the foundation of those structures that would guide us in terms of what our expectations for GPR might be in assessing those, and then use that as a model to continue to look for the fort. And that's, as an aside, part of what I've been doing in a pre-contact archaeological context, to say, what would a cedar plank house look like? And how would we model that? And how would we know when we found it? And are there lots of false positives in terms of other things that would look like that? And even down at Fort Vancouver, when we did the WSU Field School, I buried a bunch of rock piles in the excavation holes that the students dug, and before we backfilled them with the dirt, I put a bunch of rock features down there and then did some GPR over them to kind of do an experimental archaeology project to see if they look like, you know, what we would expect them to look like, knowing what they actually physically are as features.
Very cool. Yeah, Bob points out there's more archaeological disturbances.
Yeah, those archaeologists.
Yeah, darn them. Well, thank you so much.